Hi students, in this video you are going to see about chapter 11 continuation relational algebra in DBMS. So what is the full form of DBMS? Database management system. So first we are going to see about what is relational algebra. So relational algebra was first created by Edgar F. Cote while at IBM. So who created the relational algebra? Edward F. Cote. He only created this relational algebra. It was used for modeling the data stored in relational databases and defining queries on it. So why we are using this relational algebra? We are storing the data in a relational database. So whenever we want to see the data, in which form we want to see the data, that we are taking with the help of this relational algebra. Relational algebra is a procedural query language. So relational algebra என்னன்னு சொல்றாங்க procedural query language அப்படின்னு சொல்றாங்க. So why we are using used to query the database tables using SQL. So with the help of this procedural query language we are taking the data from the database with the help of this SQL. So to query the database tables so query means we can say as a question, but here query means we can say as the command. So based on our command we can take the data from the database. Relational algebra operations are performed recursively on a relation. So relation means a table to yield an output. So what output we are expecting, till that we can execute the relational algebra again and again. So recursive means repeating the process only, we can say as a recursive. The same set of commands we can repeat again and again till the output we get. The output of these operations is a new relation which might be formed by one or more input relations. So here we are doing all these works in the form of tables. So when I am taking data from the table, the result also I get in the form of a table. Next, relational algebra is divided into various groups. So first one, unary relational operations. Next one is relational algebra operations from set theory. So we have two relational algebra groups are here. So first one, unary relational operation. In this we have two operation. First one is a select, next one is a project. If you see the select in, we have this symbol. So select means we have to use it this symbol. Like that project means we have to use the symbol what they given here. Next one, relational algebra operations from set theory. So you all well known about set theory, already you learned in mathematics. The same logic you can apply here also. So union, intersection, difference, Cartesian products. So each set theory have its own symbol. So whenever we want to apply this set theory, we want to use this operations. Okay, so first we are going to see select. So select means we are selecting the particular data from the relation, that is we are selecting particular data from the table. So see here how to use the select symbol. We have to write general form. So generally they given here, we have to write the select symbol. Below that we have to write C. So this we can say as a base. Next open bracket R, then closed bracket. So R means a relation, so that is the table name. So C means a condition. So what condition? So we have attributes on the table. So attributes means each column we can call it as a attribute. So each column we are applying some condition. So that only they are saying as a C. So the select operation is used for selecting a subset with the tuples according to a given condition. So based on some condition we are retrieving data from the tables. Select filters out all tuples that do not satisfy C. Suppose condition it's not satisfied, it won't show any data to the user. So now we are going to see one example. So one table they given. So the name of the table is a student. If you see this table, we have 4 columns and 5 rows we have. first column student number, second name, third column course, fourth column year. If you see each row we have a student's details. So student number we have, name we have, course, what course they choose that we have, then which year they are studying. So all these details we have in the table. So from this table I want to see which students are belongs to big data course. So how can I select that course? Means first I have to write the select symbol, then what is the condition? Course. So course column I have to choose, from that column only I am going to apply the condition. So course we have to write below the select symbol, then equal to sign. So within the double quotation we have to mention the data name. So table what data we have, so that data we have to write it. After that inside the bracket we have to mention the relation name, that is the table name. So like this only we want to write the select operation. If you see now that we get the result, so the result also in the form of a table. So which student they choose the big data course, that alone we can see in the output table. So how we can get the output in the form of a table? So this is one example for a select operation. This here if we use a select operation we can see a row. So we can see a complete details of a particular student. Okay, next we are going to see projector. So project symbol they given here. The projection eliminates all attributes of the input relation but those mentioned in the projection list. So projection what it do na, which attributes we mentioned in the query, that alone it display. The rest of the attributes it will eliminate. The projection method defines a relation that contains a vertical subset of a relation. So if I want to display only the column na, I can use the project operation. If I want to display only the row means I can use the select operation. So now we see how to write the project operation. So first we have to write the project symbol, next we have to write which column we want to see. So that column name we have to mention here, that is attribute name. So after that we have to mention the table name within the parentheses. So if you see the result, we can see here what condition we mentioned here, course. So it display only the course column. If you see here you can get one doubt. Here we have a 4 rows but here it displayed only 3. Why? Means it eliminates the duplicate value, that means here big data came 2 times. So if we take the course na, only one time only it will come, so it eliminate the duplicate values. So this is the result of a project operation. Next we are going to see another example. So here one column only it list out first. Next I want to see the 2 columns. I want to know which student choose which course. So that time I have to mention student number and the course in the condition place. So that time it display the student number as well as the course column. This is another example for a project operation. Next we are going to see union. So these are the set operations. Already you well known this one. So union means we need 2 tables. So table A and table B. Here 2 tables they given. So now we are going to combine these 2 tables. So for that we are using a union. So union symbol is it's look like a U. It includes all tuples that are in tables A or in B. It also eliminates duplicates. Set A union set B would be expressed as a union B. So when we are doing the union set operation, that time if we have any duplicate data, suppose one data is repeated again, it will eliminate that. If we see the result, you just see here table A and table B are combined here. So this is the result of union operation. If you see here, table A it contain CS1 student number 1 Kannan name. Table B also contain the same. So likewise CS3 also repeated in a table B. If you see in the result table, we can see only one CS1 and only one CS3. So it eliminates the duplicate values. Next we are going to see the set difference. The result of A set difference B is a relation which includes all tuples that are in A but not in B. So when we are using set difference, what will happen na A la and the data iruko but B la irukadu. So like that data we want to display na, that time we can use a set difference. So the attribute name of A has to match with the attribute name in B. See the result, table A set difference B na CS4 Padmaja. So it just showing only Padmaja. Just we see the table. If you see table A and table B, so CS1 is here, CS1 is also here, CS3 is here, that also here, but CS4 it's not in table B. So what is the condition na? The data is in table A. Table A la irukono but table B la irukka koodadu. And the data mattum dhaan display pannom set difference. So CS4 is only available in table A. That's why it's displayed only CS4. Next one is the intersection. So intersection na it display only the common data. Rendu table liyum endha data common ah irukko adha mattum dhaan adu display pannom. So defines a relation consisting of a set of all tuple that are in both in A and B. However, A and B must be union compatible. So rendu table ime endha data common ah irukko and the data va mattum dhaan adu display pannom. You just see the example table they given here. So this is the result of table A intersection and table B. Next we are going to see product or Cartesian product. So symbol is the X. So cross product is a way of combining two relations. So why we are using this cross product na, we want to combine the two tables. So the resulting relation contains both relations being combined. If you see the resulting table, we have both A table and B table also. So how we can do this na? A into B. So that means A product B means A times B, where the relation A and B have a different attributes. But if you see actually na, A table have a different attributes and a B table have a different attributes. So here one diagram they given. Table A we have 1, 2 and 3 they given. Table B we have SR. So table A 1 is there, 1 irukka, other table B la irukka rendu relations rendu tuples கூடயும் வந்துட்டு merge பண்றாங்க. So likewise they done everything. So table A into table B. So one பார்த்தீங்கன்னா S இருக்கு, another one we have R. Likewise 2 and 3 also. You just see one small red color box they given. Table A is equal to 3, table B is equal to 3. So table A we have 3 rows, table B we have 2 rows. So we are multiplying these two, we get the answer as 6. So in the final, that is the result table, we have 6 rows. You just see here table A and table B is here. Now we are going to apply the Cartesian product. The result table it contains see here 9 rows are there, 9 rows. So why we are using this na? So I want to know which each student what are the subject they choose, what are the course they choose. So I want to know particular student choose what are the courses. So that time we can use this Cartesian product. That's all children. So in this video you learned about relational algebra in DBMS. So we have two types of relational algebra. One is the union relational operation, another one is the relational algebra operations from set theory. Just work out with the help of the book. So book examples they given, so you just design the table yourself and apply these operations and check it. Thank you students.